In this lesson, we're going to talk about explicit arithmetic sequences. We're going to talk about definitions and notation, and we're going to jump right into some examples. First, we need to look back a little bit. So let's review. A recursive formula relies on the previous term to determine the next term. So here's an example of a recursive formula. The first term is 15, and to find every other term, we add 5. That's what the formula looks like. So the first term is 15, and then we take 15 plus 5 is 20, and then 20 plus 5 is 25, and 25 plus 5 is 30. That's the first 4 terms of the sequence. Notice, to be able to get this term, I have to know the one before it. If I asked you to find a sub 20 using this formula, you got to go all the way through a sub 19 to get to a 20. It's kind of tedious. And that's where a recursive formula comes in. One that would just give me the definition of what 20 is without having to find all the ones before it. So as I said, an explicit formula of a sequence allows you to find any term in the sequence without having to find the previous terms. Here's the formula for what an explicit formula it always looks like. You can find a sub n equals whatever the first term is plus n minus 1 times the common difference. So n being the number of term, a sub 1 being the value of the first term, and then d equaling the common difference. Let's take a look at what that looks like. Let's take a look at an example. So this was our previous example of 15, and then we added 5 to get the second term, and then we added 5 again. So now we have 2 5s to get the third term, and then we added another 5, so now we have 3 5s to get the fourth term. You'll notice that I have 3, like I said, and I'm finding the fourth term. 2 5s was the third term, 1 5 was the second term. That's where the n minus 1 comes from, is I'm going to use 1 less of whatever the common difference is for the term that I have. So if I'm finding 10, I'm going to do 10 minus 1, which is 9. I'm going to do 9 of those common differences. If I'm finding term 20, I'm going to do 19 of those common differences and add it to the original term. So that's where the formula, how the formula is derived. So a sub n would be our first term, which was 15, plus n minus 1 is always going to stay n minus 1, and then the common difference was 5. And that's what our formula is. Now, if you want, you can multiply that out and make it 5n minus 5, and we can do 10 plus 5n, so that if somebody was trying to find the 100th term, they could just do 100 times 5 plus 10 instead of doing 100 minus 1 times 5 plus 15. But either one of those would give you the nth term without having to find all of the previous terms. Let's look at an example. Write and simplify. Let's look at another example. Write and simplify an explicit formula to represent the arithmetic sequence. And here's the sequence. Already I'm noticing that it's going up by 3. That's what makes it arithmetic. It says to write and simplify an explicit formula, which means I want a formula that will give me any term without having to know the previous one. Now find a of 26. So let's find the formula. So we can use that pattern that a sub n equals the first term plus n minus 1 times the common difference. So the first term of our sequence is 16. N minus 1 is going to stay n minus 1, and then the common difference is 3. If it was going down, you would use a negative 3. So if it's a common difference that's decreasing, then use a negative there. It says to simplify it, so let's do that. Because if I'm having to find the 26th term, I want to have the formula be as simple as possible. So I distributed the 3, multiplying that into the parentheses, and then I'm going to combine my terms. And there is my simplified explicit formula. This is for any n at all. I can find it. So now I can find the 26th term, a sub 26, without having, did I hit that home yet? To find 1 through 25. Now I'm going to put 26 in for n here. If I had put it up in the original one, it would have done 26 minus 1, which is 25, times 3, because there are 3 25s, 25 3s to get to the 26th term. But once you simplify it, all you have to do is put in 26 and then calculate what's here. So 3 times 26 is 78, plus 13, choosing to use my calculator, a sub 26 equals 91. So the 26th term in this sequence is 91. If you've got some extra free time, feel free to count out plus 3 plus 3 plus 3 plus 3 and see that it actually does end up at 91. Hopefully now you know how to write and use explicit arithmetic sequences.